Have you ever looked at a vast expanse of ice, maybe in a picture or even in person, and noticed intricate lines crisscrossing its surface? Those aren't just random marks. They tell a fascinating story about the hidden forces at play beneath our feet. Stresses create ice cracks because ice, despite its solid appearance, is a dynamic and somewhat brittle material that responds to various forces by fracturing. When the internal or external pressures on a body of ice exceed its strength, it will crack or cleave to releases that built-up tension. The why behind these cracks lies in the physical properties of ice and the relentless influence of its environment. Ice is technically a viscoelastic material, meaning it behaves like a solid but can also deform slowly like a viscous fluid over long periods. However, when forces are applied rapidly or are too intense for its slow deformation, it behaves brittly and breaks. These forces, or stresses, come in many forms. First, consider thermal stress. Ice expands when it warms and contracts when it cools, just like most other materials. When temperatures fluctuate rapidly, the outer layer of a glacier or an ice sheet might change size faster than its interior, leading to internal stress that creates cracks. Then there is gravitational stress, especially significant in glaciers. As a glacier flows downhill under its own immense weight, different parts move at different speeds, stretching and pulling the ice apart. This differential movement is a major cause of crevasses, which are deep, open cracks often found in glacial ice. Another powerful source of stress, especially for large ice shelves or sea ice, comes from ocean currents and tides. The constant pushing and pulling of water can exert tremendous shearing forces on the ice, bending and breaking it. Furthermore, internal stress can build up from the accumulation of snow or the pressure of surrounding ice masses, creating areas of localized tension that eventually lead to fracturing. Understanding these cracking patterns allows scientists to read the story of the ice. For instance, specific crack orientations can reveal the direction of ice flow or the prevailing stress fields in a region. Small cracks, called microcracks, can even influence how sound travels through ice, giving us clues about its internal structure. These cracks aren't just damage. They are vital indicators of the ice's health and movement. So, the next time you see a seemingly simple sheet of ice, remember that it is constantly responding to a complex interplay of forces. These stresses, from temperature changes to gravitational pull, are perpetually shaping and fracturing the ice, revealing the hidden dynamics of our polar environments. It is a powerful reminder of nature's constant motion and its incredible geological artistry.